Hello and welcome to this module on carbohydrates. Let's do a carbohydrates overview. Now, carbohydrates are biomolecules consisting of carbon, oxygen, and hydrogen. And the hydrogen-oxygen ratio is usually 2 to 1. The empirical formula of carbohydrates is the following. You have carbon here on the left and you have H2O on the right. So for every carbon there is an H2O molecule that is present. And for every carbon there is 2 hydrogen molecules that is present. Now, carbohydrates are broken down to CO2 via oxidation reactions. And oxidation reactions are also known as burning or combustion. Let's talk about monosaccharides. Monosaccharide is a single carbohydrate molecule, also known as a simple sugar. To the right here you see glucose, an example of a monosaccharide. And the formula of a monosaccharide is what you see here by the arrow. Examples of monosaccharides include fructose and galactose as well. Let's talk about disaccharides. A disaccharide is 2 monosaccharides bonded together. The bond between 2 disaccharide molecules is also known as a glycosidic linkage. And glycosidic linkages are formed via dehydration reactions. And glycosidic linkages require enzymatic catalysis to occur at a significant rate. Let's talk about lactose. Lactose is an example of a disaccharide. It's composed of galactose and glucose linked together by a glycosidic bond. Here you see that for galactose and glucose to link together, that has to happen via a condensation reaction, where there is a loss of water molecule, forming lactose. For lactose to be broken down, that occurs via a hydrolysis reaction, and that requires a water molecule to join in and break the lactose into glucose and galactose. Now let's talk about sucrose. Sucrose is composed of glucose and fructose linked together by a glycosidic bond. And to the right here you see an example of a sucrose, and you can see the glycosidic bond right here. Now let's talk about hydrolysis of glycosidic bonds. This is a thermodynamically favored reaction. However, it requires enzymatic catalysis to occur at a significant rate. And the way hydrolysis occurs, as we just saw with lactose, is the following. It requires the disaccharide as well as a water molecule to join in. You can see that with the addition of water, the glycosidic bond is broken down. So here's the glycosidic bond, and it's been broken down over here. The result is, in the place of the glycosidic bond, now there is 2 hydroxyl groups. You can see that the water molecule remnants are still here. There's the OH here from the water molecule as well as the hydrogen here from the water molecule. And that concludes our module on carbohydrates.